finalists for the NCIDEA grant, which obviously is a big sponsor of ours, so we're grateful to them. You're going to hear an accent. The accent is not from Fayetteville, but please welcome Jordan and his company Phinite, who is solving a big problem here in North Carolina, as we all know. Welcome, Jordan.
So everyone, Phinite's making a new waste management system for big animal farms. We recycle the material from farms and turn it back into fertilizer. The world needs more food. So the world needs to figure out how to feed 9 billion people by 2050. We need 70% more food production in order to do that. The reason this is a problem is a basic mismatch between the way food production growth works and population growth. Population growth is exponential in nature, whereas food production growth is usually linear. And so eventually population growth will exceed food production and people will start to starve. And that's really a problem we're going to be faced with within our lifetime. The way food production has been able to meet population growth historically has been through essentially the cultivation of the American West and other new parts of land all over the world, and the use of mineral fertilizers to improve productivity of that land. Fertilizer prices are starting to rise. Nitrogen fertilizer is linked to fossil fuel production, and so fossil fuel price rises mean increases in the cost of nitrogen-based fertilizers, and phosphorus-based fertilizers are also rising. In 2008, the price of phosphate rock rose 800% temporarily due to supply-side constraints with supply, and basically phosphorus will never be as cheap as it is now globally. And so we feel the biggest the biggest resource that's available for phosphorus fertilizer supply is within manure from animal agriculture, and we seek to recycle that material and produce renewable organic fertilizer. Making an impact in animal agriculture leads to huge numbers, a huge global opportunity. Waste management in animal agriculture is really unsustainable, and being able to recycle the material from farms, basically every farm in the world produces fertilizer that's worth about $20,000 a year, and globally that leads to a resource more than $8 billion worth of fertilizer. And fertilizer produced from farms is totally renewable, so that supply exists forever. Rather than mines that have a finite life, being able to mine the material from farming will last for as long as the farms continue to exist. Selling our new solution just to hog farms globally is a $50 billion opportunity. Dairy farms, the numbers are the same kind of size. So the reason people are not achieving this at the moment, the reason why people aren't recycling material from farming right now is basically to do with moisture. So manure is really wet, and technologies that are used to dry out material to make it economical to transport it long enough distances for it to be used as fertilizer. Those technologies are really expensive to use, really complex to operate, and farmers don't want them. The performance of those technologies is low, so dewatered manure has about 0.5% phosphorus in it, whereas a normal mineral fertilizer has about 20% phosphorus in it. And so a manure-based product is 40 times less concentrated than a mineral product, and farmers really care about input costs, and no farmer is going to buy a product that costs them 40 times more to spread on their fields to use as fertilizer, even if it's renewable. So basically at Phinite, we have solved dewatering. We've developed a new agricultural dewatering system using constructed wetlands that dry out manure naturally using evapotranspiration with plant roots. And this makes the technology extraordinarily low cost, totally natural and really easy to use. And so applying this technology to farming for the first time means that we can recycle material cost effectively and produce organic fertilizer. Just a comparison with existing dewatering technologies. So these things here are called centrifuges. They're used on every wastewater treatment plant almost in the world. What they do is they spin material around at really high revolutions and separate material by spinning it. And so they're really expensive to build, really complicated. Like if you look at these things, they're an industrial product. Putting one of those on a farm seems crazy. How's a farmer ever going to be able to maintain and operate something like that? They need a lot of electricity, and their performance is really low. So the driest material that you can get out of a centrifuge is about still 70% moisture. And so if you're going to transport this material, you're paying to haul 70% water anywhere you're going, compared to a mineral fertilizer, which is completely dry. And so our constructed wetlands, the future of dewatering is a technology that's simple and low cost. Constructed wetlands have no moving parts. They're completely solar powered, and they're high performance. So you can get material that's 2 to 3.5 times drier than coming out of conventional technology with a centrifuge using a constructed wetland. Here in North Carolina has a waste management problem with farming, as you all know. We've compared the available options that exist for farms to dispose of sludge material that has been building up in their lagoons. The normal method is to pump and haul this material and land apply it within about 3 miles of a farm. And the lowest cost dewatering technology that's available to farms is a thing called geobags, which cost a farm about $300,000 over the next 30 years to use. And we've modelled and found that our constructed wetland technology is $200,000 cheaper than geobags over 30 years, and is similar. It's cheaper than pumping and hauling when the distance to apply this material is more than 4 miles. Here in North Carolina, farms have to compete for space in order to apply their material, and there's basically no future for this sort of conventional practice of pumping and hauling of waste. And that's why we're here in North Carolina, because the existing practice isn't scalable anymore, and there needs to be a new option. So basically what we do is at Phinite is we market this constructed wetland technology directly to farmers. Farmers pay us to build this system on their farm. Farmers operate the system for the life of the farm, and farmers guarantee to give us the dried out material that is left. So after about 10 years, this wetland will fill up with dried out material, which is great fertilizer. Farmers dig that material out of the wetland, supply it to us, and then we reprocess it and sell it as fertilizer for $5,000 a tonne. The wetland then is returned back into operation, and the wetland survives for as long as the farm does. It's built in the same way that lagoons are built on farms, so it has an asset life of at least 80 years. Our revenue model, so a normal farm sells for about $120,000 a normal wetland to a farm. We make about $60,000 profit on that. There are 3,800 lagoons in North Carolina that are active, and so there's a market potential of $450 million, $225 million worth of profit potentially. The fertilizer resource that has been building up in farms in North Carolina for the last 30 years is worth about $610 million. An ongoing supply of fertilizer from farms is worth another $20 million in annual recurring revenue. So Phinite, we launched the company in April this year. We built our showcase demonstration system on a farm in Bladen County. This is a contract nursery farm to Smithfield Foods. We built it and then commissioned the system in August this year, and now have demonstrated that the technology works to farmers here, and so now we're ready to do sales. We've applied for an NCIDEA seed grant, and the money that we're going to use, what we're going to use that money for is for sales. This is a real opportunity to improve one of the poorest areas of North Carolina. There's a lot of local employment opportunities in building the wetlands and also in remanufacturing the fertilizer for sale. And so there's a real opportunity to do something good for people of North Carolina by adopting this technology. This is our team. So myself, I'm CEO and founder of Phinite. Michael Inman on the right here is the owner of our showcase system. We have a direct sales model to farmers, and Mike is a member of the board of the North Carolina Pork Council. So he's really well connected and introduces us to basically sales prospects, and that's really important to us. Like, you can tell I'm not from around here, but like, hog farming is a really tight-knit community. There hasn't been a lot of new people working into it, and so trust really matters to these people, and so personal introductions from people that they trust are really valuable to us. Scott Wallace at the bottom here. Scott Wallace is one of America's leading constructed wetland engineers, has designed more than 250 systems all over the world, and holds 2 patents on constructed wetlands. And so he is helping us as well. So that's our team. So what I wanted to come to do today was to speak to you about what we're doing and see if you can help. So I'm looking for introductions to other people that are interested in working on waste management, animal agriculture, and also just sort of sustainability in general. Looking for co-founders and potential team members to come work for us, and generally just to understand better the community for ag tech startups here in North Carolina. Thanks.
All right, open it up for questions. When he picks you, please stand up and project your voice.
Okay, I grew up on a farm, and so this is pretty cool stuff. But I had several questions about it. How does this compete? I've got 5 questions if you got time. How does this
one at a time. We got a lot of.
All right, we'll go around. All right, so I'll choose the top one. It seems like anybody could do this. What protects you from other people getting into the same space?
Yeah, so basically, constructed wetlands have been around for a long time, but nobody has been able to make them work in this application in animal agriculture before, and the reason for that is because the manure is very strong. There's a lot of ammonia and a lot of organic matter in there, and that kills the plants. We've figured out how to make these work and have a patent pending on the sort of system that makes that work, and it does. Like, you've seen it work.
Eric, did you have a question?
I want to hear his questions.
There's a question.
Sorry,
in the back.
okay.
Well, hold on.
Right.
There's a question back there in the red shirt.
I'm sorry, I walked in towards the end. Since you're dealing with the manure, the waste, is there a component that deals with the smell? Because that's a big issue here.
So not with our technology. Basically, the lagoon spray field system that's used by all hog farms in North Carolina is designed to take 30 years to fill up with sludge. And the sludge is where 90% of the manure nutrients are stored. And basically all the farms were built 30 years ago. All the farms are full. All the manure is going to be spread on fields now. So no, we don't deal with odor, we deal with the sludge. And actually we feel like that's a bigger problem that's not being talked about. Basically 90% of the nutrients on a hog farm end up in the sludge over 30 years. Like, a normal 4,000 head hog farms produces about as much waste as a community of 40,000 people. And there's 4,000 farms that all have these lagoons. So 4,000 times 40,000, is that 1.6 billion people's worth of stuff that's going to be spread on fields in the next 10 years? Like, it's a huge amount. And it's, yeah, just sort of flying under the radar at the moment.
Frank?
Yeah, during your presentation you talked about the pricing and the cost versus if you're more than if the lagoon is more than 3 miles away. Can you go over that again? I wasn't quite sure how that value works. And the second part of that is, based upon that, how are you going to scale? Because it sounds like there's a really big opportunity. I just wanted to hear investment growth plans along the way.
Yeah, so can you go to that map that I showed? So we've done some basically proximity analysis of farms here in North Carolina just to show you how how sort of intensive they are. So these are Duplin and Sampson counties, the most intensive states in North Carolina. These red dots are farms that have more than 45 farms within 3 miles of those farms. So these areas, there's more than 45 farms that are all competing for the same land to apply their waste. And second to that, the poultry industry is almost as big as the hog industry in these states, these counties. And so basically there's not enough land, and that's why people have to start going further afield to spread the material. But even 3 miles is, there's not land within 3 miles for a lot of these farms to apply their stuff. And so we act as a sales and engineering design company. So we make direct sales to farmers, we design the system, we subcontract civil construction contractors to build the wetland, and then the farmer commissions it based on our instructions. And so scaling is essentially the same as what it would be if you were scaling a small consulting company. It's all people and intellectual property. The way we price the system is so that cash flow for supply of materials to build farms is supplied by the farmers themselves. They pay a deposit up front that pays for all the materials in order to build it, and so we don't need to be positioned with our own cash on delivering the projects at scale, which is like there was obviously a lot of money that would be involved in building these everywhere, but the farmers supply that themselves.
Jordan, there's a question by Steve right here.
Yes, Steve.
Morning. So I imagine that at some point when you have your production, at some point when you have your production unit installed and you're getting ready for it to dry, harvest the material for phosphorus, suddenly it rains and your stuff's all wet again. So do you have to cover it, or what's involved in actually waiting for it to dry, and what's your impact of water?
Yeah, so these wetlands are designed to take 10 years of operation before they fill with material. And rain, like it's remarkable that rain actually doesn't re-wet this stuff that much. Once you dry out this sludge, it doesn't get wet as much. And the plants, the roots that grow out through the material as the system fills up, they can pull that moisture out quite easily. So we aim, there's usually a soil moisture deficit in North Carolina during August and September, and they're the months that we plan on digging the material out when it's released.
Eric?
So you mentioned direct sales to farmers. What does that look like? How are you connecting with them? Where are you targeting? Like, can you just elaborate on that?
So Mike Inman, the farmer that we have at the moment, is making personal introductions to farmers that he know are sort of checkmated in here with other farms around them, so they don't have any space. And also we're working with the North Carolina Pork Council, doing work with their newsletters and industry publications to get our name out with them. But it's sort of early days with that at the moment. But that's how we plan, like becoming a trusted member of the community with sort of impeccable technical credentials is how we plan on getting trust and then getting sales. So we're targeting, like what we'd like to do is get a system deployed in each of these central areas, and then the farmers can go visit them. But these people talk a lot amongst themselves, and so once someone does something, everyone is very interested to find out why and if it works for them.
So do you have sales already?
No, not yet.
Question in the front, Rick?
Good presentation. Two things. Can you sleeve this process into existing wetlands?
What do you mean?
Natural wetlands.
No.
You can't do that?
No.
Okay. And have you, because there's a lot of revenue doing that. So the other thing is, are you working with frontline farmers and Golden Leaf on this?
So I know Golden Leaf, I don't know frontline farmers. What are they?
They've been doing this process. They've got money, a pool of money. They've been trying to deal with hog lagoons and chicken.
Okay.
I could talk to you offline.
Yeah, please, that'd be great.
There's a second question in the front row, the lady at the end.
Hi. So as we saw during Florence, there's a lot of issues with lagoons and containment. Does your system address that waste containment during extreme weather events?
That's right. Yeah. So our system was there during Florence. It coped with it very well. But these are designed they're designed to store that water. And actually, like relative to other options, they're much better for being able to, like once our wetland captures water, you don't need to put it into the lagoon straight away. And once you remove sludge from the lagoons, it is easier for farmers to manage the level in those lagoons so that they don't overflow, which was a problem that happened in Florence.
Question here.
So I understand that these farmers don't have a better alternative. Like they don't have space, they pay you now for a payback in 10 years. It's probably the best option, but it seems like the potential of you being disrupted by somebody coming up with some technology that does this on the fly is pretty high. So what does the technology space look like for centrifuges and better options that way?
Yeah, so basically there hasn't been an innovation in dewatering technology for more than 50 years. This is a really, really stable area, and these wetlands are by far the most disruptive technology in the space. They're moving, there are about a few thousand of these things that have been built in Europe now, replacing sort of the mechanical based dewatering technologies that are there, and they're the best option that's out there. Like it's very unlikely anything else is going to come up. Like I didn't start with constructed wetland technology and then discover North Carolina and go, hey, this is a great market for my thing. I started with the farmers in North Carolina, figured out what the best option was for them, and then invented the constructed wetland technology from there, this application of them. So it's, yeah, like any on-the-fly thing has some very, very big challenges associated with it that I can explain separately, but it's not easy.
Question in the back here, over here.
Question. For instance, hog farmers, and I have a friend who owns about 57 of us. They've become like daycares, you know what I'm saying? The profit margin is that much. But have you seen this technology where it's a greenhouse, the biggest greenhouse going towards Charlotte? What they do, they take that, remember you showed some of that technology showed right over there. They take that, whatever, from the lagoons and take it to them, and they burn it and all that stuff and make it organic and all that stuff. So I visited the place about a month ago, and I know the guys very well. So what they do, they'll bend that thing to make it organic. And I asked the guy, how long does it take to pay off the machine? You show those machines right over there. And what they found out, they put some the pH, you know, the water they had to treat the water and all that, because it wasn't coming out as organic and all that stuff. But they bought that system you have right there, but it took them almost about a year and a half to pay off that machine and all that stuff. Because most of farmers, they're constrained with their profit margins less than 3%. Yeah. And most of them, they sell that lagoon and somebody else brand it and use it, you know, even to use the greenhouse, they use it for energy and all that stuff, you know what I'm saying? And some of it, they use it for, when those are waste stuffing, they use it as organic and all that stuff. And my concern to them, I asked them, hey, how long did it take you to pay off this machine, and what was set up for any sense? It took me like a year and a half, I paid it off, because most of farmers, their profit margin, they cannot do that. If you look deep into that, because most of farmers, their profit margin is about 3-5%.
Yeah.
How does that work with your technology?
So I guess there are two things. Farmers now have paid off their farms, and so their profit margins are low, but they're not paying off their assets anymore. And so farmers are actually looking for new depreciable assets to build on their farms. A lot of them are buying tractors and things in order to depreciate those things away. And so this is another depreciable asset that's available for them, and that's one of the big cost advantages for us. This is not a waste disposal system that you can't depreciate, because it produces something of value. It's worthwhile for farmers to do that.
Okay, we need to move on to the second speaker.
One more question.
One more question. What about E. coli has been a big problem with spread fertilizer, you know, from farms that, you know, gets on vegetables and things like that. How does this prevent that?
Yes, this stuff is, the E. coli can't survive once the material dries out for very long. It's not an issue. Like, this is essentially a passive composting system. The bacteria are gone.
Okay, thank you very much.
Thanks, everyone.
will you be around for a few minutes after the presentation? Because this gentleman had 3 more questions, I believe. Okay. Okay, so we're switching presentations. Yeah, grab some coffee, because we didn't have it set up before, so we'll give you a minute or two to caffeinate, because that's why you guys come, right? Isn't that why they go to North Dakota, 400 people, so they can warm up? It's the only place in town with a heater. I can make that joke because I was born in North Dakota.